All right, welcome to a lesson about the segment ratios assignment. So basically what's happening, yesterday we got midpoint, which is finding the point halfway across. Today you're supposed to find a different point, and that point is going to make some ratios. So on this starting example here, you're trying to find the point such that the ratio from A to C to the if you just have two letters, it's the distance. So it's the distance from A to C. Over the distance from C to B is going to equal 2/3. So basically, this is going to be 2 and 3, but it's not necessarily those exact numbers because it's a ratio, it's been reduced. So this could be something like 10 and 15, or it could be, I'm trying to think of this, 20 and 30. It just needs to be a pair of numbers that the ratio is 2 to 3. And so it's kind of a complicated process. We're going to walk through it, but you should be able to. There is an actual algorithm for it, and so we'll get there in a second. But first, we need to figure out how long this is, which is pretty easy to figure out. It's Pythagorean theorem. Figure out how wide it is, which is 6. Figure out how tall it is, 8. Square them, add them up, square root that. It's 10. So the distance is 10. So that's the length from A to B. So now we're going to be doing some algebra to figure out how long these pieces are here along our hypotenuse of the triangle we just made. So you need to know that the distance from here to here plus the distance from here to here is equal to the entire distance. That's the segment addition postulate. And the reason we do that is, you'll see why in a second. But yeah, we're going to do that and then solve for AC, which is a number we don't know. We do know this number already, it's 10, but we're going to keep it out for a bit because you'll be applying to all situations. So now we have that equation solved for AC a little bit. We're going to substitute that in for AC into our little ratio up here at the top, right? AC over CB equals 2/3. So we're going to substitute that in, and it makes this little fraction here, and it's going to equal 2/3. And the reason we did that is because now this is a known value. It's 10. It's up here. We already got it. And so we can solve for CB now. And so I'm going to times both sides by CB. So times CB. And I'm going to times both sides by 3 to get just things out of the denominator. Times by 3 times by CB. And do some simplifying, and you get an equation looking like this, which I want it to just say, I want it to be all the CB's on the same side. So I'm going to add 3 CB over, and we get an equation looking like this. 3 times the distance from A to B equals 5 times the distance from C to B. If you want all the work, it's there. So now we got that. Now we have this equation. We can actually do some solving. We can plug our 10 value in. We know this is 10. That's back first step here. We know how long the entire length is. It's 10. So we're going to substitute that in and solve for CB, which is the distance from C to B. It comes out to be 6. And so I now have that C to B here is 6. Well, if the whole thing's 10 and one part's 6, the other part's 4, and that's what this last thing's saying. We already know the distance from C to B, it's 6. Just plug that into our equation we had way up here, the postulate. And you solve, you get 4. So we did all that work, and now we have that this part is 6, this part is 4, and that ratio does come out to be 2/3, right? Because 4, 6 reduces to be 2/3, which is the distance from A to C over the distance from C to B. Okay, awesome. So we did all that work to get this. And if you remember, the entire distance is 10. Well, you can use the fact that these, when you draw them, make similar triangles. We got the big triangle, and then we got a similar triangle here, and a similar triangle here. They're similar by different ratios, but you can use the fact that they're similar triangles to find these x and y values. And so I'm going to switch colors here. Well, let's start with this triangle. If I get, sorry about that. If I know this is 4, then I can take this entire distance and times by the scale factor that made me go from 10 to 4. to get this distance here, this will give you the same x value here. So let's go ahead and do that. Let me do some erasing here. So 10 times something was 4. You just divide by 10, and you figure it out. You times by 2/5. So this triangle here is 2/5 the size of the big one, which means I can take this distance times by 2/5 and get this this distance here. So let's go ahead and get that. 6 times 2/5 is going to equal that distance there, which comes out to be 12/5. And so I'm going to take this number, add 12/5 to get this point, which has the same x value as that one. So this x value is going to equal -2 plus 12/5, which is going to equal 2/5, conveniently enough. And so the x value is going to equal, I'm going to write it out, -2 plus 12/5, which comes out to be 2/5. Awesome, we got that. Time to switch colors. Let's do blue. So we got the x-coordinate. Hooray! So now we're going to get the y-coordinate, which we can take a similar path. This triangle up here is similar to the big one. And if I take my side here and times by the scale factor, I can get this distance and use 7 and that distance to get this y-coordinate down here. So that's what I'm going to do. You take 10 times by something to get 6, and you take 8 times by that same thing to get this distance here. So let's go ahead and figure that out. I'm going to use over here just 10 times something. I'm going to use triangle because I use question mark. It's going to equal 6 divided by 10. And triangle is 3/5. So that's our scale factor. So I'm going to take 8 times by scale factor, and that'll give me that distance. 8 times 3/5. It's going to equal that distance, which is 24/5. And now I know this entire distance. I can take 7, which is this y-coordinate, subtract off the 24/5, and that'll give me this point, which is the y-coordinate for this point. So I'm going to do that. Do some erasing, sorry. So 7 minus 24/5 is going to equal that coordinate there. 7 is 35/5, so I'm going to subtract that off. And that'll give me 11/5. So this y-coordinate is going to equal 11/5. So all together now, I have that x is 2/5, y is 11/5, so C is at 2/5, 11/5. Whoa, that was bad. 11/5. Ta-da! So we did all that work using similar triangles. You figure out these segment lengths here. But I want to mention that we actually don't need to get these individual distances, because if you look at our scale factors, which our scale factors were 3/5 and 2/5. Scale factor 3/5. Scale factor. Oh, sorry, the other scale factor over here. 2/5. Those numbers are related to this ratio that we had to start with at the beginning. We got 2/5 and 3/5. So it's these two numbers on top, and they're both over them added together. And so you got 2/5, and we got 3/5. And those are the two ratios, scale factors between the large triangle and the small ones here. And so you can use that knowledge to help you get these coordinates faster. You can pretty much skip all of this stuff and just realize the scale factors are going to be these numbers over them added together. And so you can use those for your different parts. And so that's what we're going to do on the assignment. So I'm going to switch to green. And if you're interested in like proofs, I guess you could read through all this stuff. But yeah, that's a lot of reading, a lot of proving stuff. We're going to skip that because this is the shortened version of the assignment. So basically what's happening is you'll be confronted with an A and B. You should plot them on there, put a C on there, because you're trying to find the coordinates of C, this mysterious point, such that they meet some sort of ratio, which in this case, we're trying to do AC over CB is 3/4. So this is going to be 3/4, but not those exact numbers, right? This could be 6 and 8. It could be 12 and 16. Things like that. Those all reduce to be 3/4 when you write out your ratios. And so we're going to use scale factor to help us out. And so if you want to get this scale factor to get AC, you just do these two numbers added, and that's the denominator. And the top numbers of these scale factors are going to be these two numbers here. Okay. And so the distance from A to C is going to be 3/7 of A to B. And the distance from C to B is going to be 4/7 the distance from A to B. Right? If you add those up, that's the entire distance from A to B, by the way. And so we have those scale factors. Hooray. We're going to use them to get the coordinates for C. You may notice on here I added some letters here, and that's just to reference those points later on. This is not going to come out to be nice grid lines. These are just approximate points. So what I'm going to do is I'm going to use my scale factor for here, which is 3/7, to use on 8 to get this distance here, and I can use that distance to take my y-coordinate of A and get the y-coordinate of F. So that's what I'm going to do. So I'm going to do 8 times the scale factor there, which is 3/7, times 3/7. Sevenths, not fourths. It gives me 24/7. And I'm going to subtract that from the y-coordinate of A. So I'm going to do A, F. The distance from A to F is 3/7 times the distance from A to D. So I'm going to take the y-coordinate of A and subtract off 24/7. And that'll give me the y-coordinate of my F point. Here, let me move this out of the way so it makes like there's an actual process here. And my y-coordinate for A is 5. So the y-coordinate of F is going to be 5 minus 24/7, which 5 is 35/7. So I'm going to subtract that off. The y-coordinate of my F point is going to be, 35 minus 24. Look, 11. It's 11/7. So that's going to be the y-coordinate for this, which is the same y-coordinate of my C point. So I got the y-coordinate now. So let's switch colors. We're going to get the the x-coordinate for E. Again, I can use my scale factor here. 11 times something is going to equal this. And I know that scale factor already, it's 4/7. So I'm going to take, I know the distance from D to E is going to be 4/7 the distance from D to B. And that distance is 11. So it's going to be 4/7 times 11. So that gives me 44/7. All right, so I got that this distance here is 44/7. And so now I can take my x-coordinate of D, which is the x-coordinate of A, which is 7, and I can get the x-coordinate for E from there. So the x-coordinate of E is going to equal the x-coordinate of A minus 44/7, which the x-coordinate of A is 7. This is going to equal 7 minus 44/7. And so my x-coordinate of E is going to be, 7 minus 44/7 is going to equal 5/7. At least I think that I did that right. Oh, crap. I realized what I did wrong. I didn't use this triangle. I was using this distance here. Aha, that's the problem. So all the 4/7 stuff actually needs to be 3/7. So I'm sorry, guys. This is 3/7. 3/7 should be 33/7, which is going to change my answer a little bit here. 33. I'm sorry. This distance we found was actually this one here, from here to here, which we could have used that, but that's okay. Anyway, 7 minus 33/7 comes out to be 16/7. So hooray, we got the 2 points. All together now, it makes 11/7 and then 16/7. are the coordinates of C. And if you convert that to decimal, you're looking at 11 sevenths is 1.57, and the x coordinate 16 sevenths is 2.28. Oh, 29. Ugh. 2.2 as your coordinates there. So there you go, fractional or decimal numbers. So that's basically what's going on. Figure out the distances. Use your ratio to help you get the right distances there. You can figure out your coordinates. Weird assignment, weird things, but good luck.